In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 3.3. I'm going to try and show you how to do this question and not just the solution. So you may need to pause and rewatch certain parts of the video. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. For most questions, I tell students if you just try them, you should be able to pick up lots of marks. This is one of those questions where I think it was very difficult to even start it. If you weren't sure what to do, you could get in a lot of trouble even starting this question. What we have here is basically two clues they've given us. They've given us two clues and ultimately they want to find Z, the X and Y part of Z. The two clues they've given us is the fact that this division here is real. That's one clue. And the next clue they've given us is that the modulus of Z is the square root of 10. We're going to use both those clues to try and solve it. They tell us, which is quite helpful, that Z is equal to X plus YI. This is extremely important because I'm guessing a lot of students seeing division, seeing Z plus 4i on the bottom row, and went ahead and multiplied this by Z minus 4i to try and get rid of the bottom row, to get rid of this its complex conjugate on the bottom row. There's a problem with that. That's not going to work out for you because Z minus 4i is not the complex conjugate of the bottom row. That's because Z has an I inside it. Z is made up of a real and an imaginary part, and you have to respect that. So we are going to get the complex conjugate. We're going to divide this. But instead of this, we're going to write this out as X plus YI plus 4 divided by X plus YI plus 4i. And we are going to get the complex conjugate at the bottom. But I think it will help to rewrite this again as X plus 4, put a bracket around it, plus y. I'll put a bracket around that just to make it really obvious. This is the real part and the imaginary part of the top row. The bottom row, X is the real part and the imaginary part is y plus 4. And they're both multiplied by I. That's the imaginary part of the bottom row. When we're dividing, we multiply by 1, which is the same as multiplying by something divided by itself, which is the same as multiplying by the conjugate divided by itself. And we pick the conjugate because the conjugate would make the bottom row real. Oh, by the way, I don't have to do all the work I'm about to do. Well, I'm not going to do all the work it seems I'm about to do. I'm going to stop them. I'll talk more about that in a moment. Let's multiply this, put a big bracket around that, and multiply this by the conjugate at the bottom. That's X minus Y plus 4. Remember that both of these are minus. Minus goes into both of them times I. And X minus Y plus 4 I. And we're multiplying by all of this. This would be a mess. We have 3 terms on the top, 3 terms everywhere in fact. So these 3 terms by these 3 terms would get 9 different terms on top, 9 different terms on bottom. We'd have to put them all together. It'd be a bit of work, not too hard. I'm guessing a lot of students did do that. It's fine. You probably only cost yourself an extra minute or 2. But also you added in the possibility of making loads of mistakes. So I'd like you to consider now what you could have saved yourself time on. They never asked us to do this. We weren't asked to divide this by this. All they did is they told us that if you divide it, the answer is real. What does that mean? That means there's no imaginary numbers in this. Now we know there's no imaginary numbers on the bottom because we're going to multiply it by its conjugate. That's what it does. It destroys imaginary numbers. If you multiply this bottom row out, the i's will just cancel each other and we'd just be left with loads of numbers. That's fine. What they're telling us is if we multiply this top row out, there should be no i's. But if you do it, there is i's. So that means they all add up to 0. Maybe we get like X plus Y I. That means they must X plus Y must equal 0. That's what they're telling us. So the work we can save ourselves is we're not going to multiply this. We're going to think about it. Where do all the i's come from on the top row? Bottom row, I know they're gone. But on the top row, where will an I come from? This real number by this real number. No, that's not going to make any i's. This real number by this imaginary number. Yes, that will have i's in it. This imaginary number by this real number, yes, there will be I there. And this imaginary number by this imaginary number, no. Two imaginary numbers will get turns into -1. Okay. So all I'm interested in is this real number. Let me write it out again. X plus 4 multiplied by this imaginary number. So multiplied by minus y minus 4. Let's write it like that. Multiply this minus. Can't forget this minus here. This will have an I in it. Sure, I'll cancel that in a moment. Then I'm interested in this one by this one. That's y multiplied by x. And that will have an I in it. But I know this has to equal 0 i's. So we just cancel all the i's there. So this is the information I'm going to get from the fact that this is real. So let's clean this up a bit. We get minus xy minus 4x. I'm just multiplying this all out. Minus 4y minus 16 plus xy equals 0. We have xy and xy. They cancel. We have everything divides by 4, and we've moved the 16 over. So let's divide everything by minus 4. We'll get x, we get plus y, we'll get plus 4, or equals minus 4. This is the information we get out of the fact that this is real. Again, if you multiplied all of this out, you would have had a big mess, but hopefully this would have been this here would have been part of your mess. They would have cancelled. You should have had this with I here, with all of these with an I in it. This should have been in the mess that you multiplied out. The secret to this question, the leap you had to take, was the fact that all of this must equal 0 if it's real. And you should have got to this information. We're not finished yet. We have 2 unknowns, 1 equation. We need a second clue. And that's what this tells us. The modulus of a complex number. This is the same as the modulus of x plus yi. Sorry, the modulus of it. And that's equal to, remember, this is, you could just think of this as drawing if you want. What's the length here? When you know this, and you know that, it's Pythagoras theorem. It's this squared plus this squared, the height of a squared, and the square root of it. But they're telling us that equals square root of 10. So just cancel the square both sides. We just know x squared plus y squared equals 10. We have, 2 clues, this one and this one. 2 unknowns, 2 equations. This is a simultaneous equation, a quadratic simultaneous equation, sure. But this is something we've learned how to do. We can solve this. Let me clear the board off and we'll do just that. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. I didn't mean to rub out the actual question or the clues they gave us, but we've reduced everything down to this, solving this simultaneous equation, which is also the same as a line hitting a circle, by the way. But how do we solve this? Rearrange the simple one here. So it's x is equal minus 4 minus y. Or you could have got y in its own as well. And we're going to put this into this. So that's, instead of x squared, we're going to put that. Minus 4 minus y squared plus y squared equals 10. 1 equation, 1 unknown. Let's multiply it all out. We get y squared minus minus by a minus is plus 4y, and there's 2 of them. So we get 8y's. We get plus 16 here, plus another y squared equals 10. Add all these together, we get 2y squared plus 8y. 16 minus 10 is 6 equals 0. Everything, 2 goes into everything. So we get y squared plus 4y plus 3 equals 0. Quadratic equation comes down to, if you're not good at factorizing, use the minus v formula. But this one does work out quite nicely. Y times y, we'll get y squared. 3 times 1, we'll get 3. And this does work to get 4. This plus this. Plus 3 plus 1, we'll get 4. So this all still equals 0. So y plus 3 must equal 0, or y must equal minus 3, or y must equal minus 1. Don't stop here. So many students stop at this point and they just throw away a mark. Maybe 2 marks, because the examiner might just have to give a mark for each of the 4 answers. The other answers are the x's. You still want your x's. X is equal -4 minus 3. So instead of y, we put -3. That's -4 plus 3. That's x is equal -1. Same here, x is equal -4 minus -1. So that's -3. You could have got x's as well, by the way, because a circle is symmetrical. So you could have just said that if -3 is the answer on this side, these go together and these go together. If -3 is the answer here, -3 must be the answer for the x here. Anyway, this I think you get full marks at this point, but you can still write this as -1 minus 3i. So that's the real part and the imaginary part. That's the real part and the imaginary part of these. These are the 2 answers to that equation. Okay, that's it for question 6. If you have any follow-up questions or see any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.